So now it says it's live.
Okay. Do we believe it? Are we live? Hello? Somebody say something? Coffee.
But someone else mentioned coffee. Oh, I see.
They,
Pamela,
they,
you said, yes, I did go make coffee.
yeah.
I
And then
understand.
I said it on the feed that wasn't live, and I have a brand new NASA coffee mug. I'm very happy with my
Nice
brand new.
mug.
Yes. And I see the stream. I'm going to pause the stream. I don't need to see myself.
Mine says the stream is starting soon, but oh, there it is. There she blows. Yay, says some people.
We are live, says Astro Hedge. Helga?
Hello,
Helga.
Giselle. Hello, Serena. Hello, Wilhelm.
Yay, everybody say hello to us,
Jonas.
and then we will say hello back to you. So now's your
Hello,
chance. Say hello.
Graham. Hello, Susan. Hi, Steve. Hi, Tuck Tongue.
Are you using the active users tab?
I am saying hi to everyone who is scrolling by in the
well.
chat.
Well, witness the power of a fully operational active chat list.
Yes.
Hello to Giselle, Graham Ash, Guido Bibra, Jessica Feltz, John Suffill, Lillian Brennan, Matt Woods, Michael Jobin, Psychocat 749, Serena Rakasha, Steve Heistand, Susan Hunter, Tech Tang, Tom Van Scotter, William Van de Beek, and Jonas Sofri. And alphabetical, even. Of course, I had to look down at my computer, which I think snapped us all out of the shared delusion. Welcome back to the Astronomy Casts, Pamela.
Hi. We actually saw each other just last week when we were both at the launch together.
Hey, Chad.
So
Bring it up.
Bring it up. Make it happen.
Where'd the picture go? There was one.
Let's see if we can give people a little sneak peek of this.
Sure.
So we watched the Osiris Rex mission blast off, and we were at the Kennedy Space Center together, and we did a bunch of reporting and shot a cool video, and which you should go and check out on the Universe Today channel. But the cool part is earlier, right there. Yeah, we're sitting on a bus. Anyway, and I don't know if you've seen the video. Have you seen the final video, Pamela?
no, I haven't.
Oh, okay. All right. Well, then, here, let's see if you can see it now. Oh, we don't even have the screen. I'll just keep killing time then.
Kill time.
Okay. Yeah, so it was amazing. Because I've mentioned this in previous episodes, right? Which was that I never got to see a rocket launch, even though I've been doing this for 17 years. And so we were in, the last time I was there was back in 2012, 11. Mm-hmm. And for the space shuttle's its penultimate launch, and there was a problem with its fuel tank, and it got delayed for a month, and so I never got a chance to see it. And bring the sound up.
Oh, yeah, sure.
All right.
In
okay.
geophysics
okay, hold on.
of this sample that we've looked
I
at
was very
with a
passionate
camera
about
and
whatever
then
I
in
was
the
saying.
lab, and now we can get what's called ground truth of what we see and what we measure.
have
Since
no sound.
1999,
But that is
we have
organic
been able
molecules.
to measure
And that's
how
Dr.
much
Matthew
the
Francis,
orbit has
also
changed.
passionately explaining things.
Yep.
So go watch the video and
Yeah.
you can hear what we're being passionate about.
Yeah, so it's a story of a plucky Canadian who's never seen a rocket launch, and we went and saw it.
And
Oh,
I feel
spoiler
like
alert,
I'm
Chad.
collecting-
Oh, okay.
Chat.
All right.
So I was feeling like I was collecting a full house because I've now seen a Delta when I saw the Grail launch. I've seen an Atlas now that I've seen the Osiris Rex, and I got to see STS 123, which is by all means the most awesome number because it's the only way I'll ever remember it.
Yeah.
It's 123.
1, 2, 3. That's crazy. People are saying I'm out of luck. Okay, is it this? Is it this? Is that the problem?
No, that's my arm.
Oh no! Whatever we do, don't show Chad. Yeah, I think it's that my camera. See, people are judging what is. Well, they're seeing the posters on the beside me, and so they're saying that means that I'm out of alignment. But
The door is just also out of alignment.
there's nothing square in this house, so don't look at the posters. Just look at me and see if I'm in alignment.
Where else would we ever look, Fraser?
But it was amazing. It was amazing to see a rocket launch for reals, and ended up we had a really great one. It was like right at sort of sunset. We had a perfect view. The sky was perfectly clear. We could see the whole rocket go up, and we could see the contrail for for an hour later. It was just wonderful, and it was great to sort of get everybody's everyone's experiences and talk to you guys, and I really enjoyed it. So if you're ever like, it's not that complicated, right? Go to Florida and you just go to Cocoa Beach, and there's a great beach for watching it, and you just watch the rocket go off. And it's not that expensive, because if you want, stay in Orlando outside Disney World, and it's like hotels are like $30 a night. It's crazy. That's what I was paying, Chad. And then just drive down to Cocoa Beach and watch the rocket go off. And
you and I both did something that I didn't do previously, and I'm very glad we did. We stayed in Titusville, which is so much closer to the entrance to Kennedy, because you don't have to like drive all around all of the crazy you can't enter without a badge entrances.
Yeah.
So stay in Titusville. It's less sexy than Cocoa Beach.
Yeah.
But my hats are off to NASA. We took a lot of the CosmoQuest team down with us, and Fraser and I were on the press side of things, where we had fabulous lighting. I can say no wrong about the lighting we had, which is what you want for press. My students and our team members were over in the VIP seating area. They had an amazing view. Lighting wasn't as good. We had better lighting. They had an amazing view, nice and close, great facility. They were over in the Saturn V facility. NASA really took great care of the press and the visitors who are part of the team. CosmoQuest is going to be working with Osiris Rex on citizen science. And so it was, hats off to NASA. They took really good care of us.
Yeah, absolutely. They changed the rules for us as Canadians, so we were foreign press, us and this poor group of Japanese videographers, and so they had to run us everywhere, because because we were foreign press, we can't have the same kind of credentials as American citizens, and so it was hilarious to see them. They just had to make all these accommodations for us, and on the one hand, they knew it was ridiculous, right? Like, we're Canadians, we're as harmless as they come, and yet at the same time, because this is the rule, foreign press, they had to drive us from the press accreditation facility to the press office. They had to drive us out to the where they were doing the launch from. It was so funny. So
and what really got me, so this is the badge I got.
The pretty pink badge.
Yeah. So I have like fluorescent pink badge. Fraser had this like glow in the dark green badge that you could not miss. And but they took great care of us. I'm going to be getting my photos up on Flickr this evening. So if you follow me on Flickr, that's where my photos will be going. It was amazing.
And I'm really proud of the video that we made of the trip. So if you go to our other channel, give it a watch. Chad did a great job editing it and shooting it, and I think you'll really get a sense of what it's like to go to Florida and watch a launch with your own eyeballs. And you don't need any special credentials. Seriously, just go to Cocoa Beach, stand on the beach, look up.
Or Titusville. You can also go to Titusville.
Yeah, but at Cocoa Beach, you're sort of around the corner, and so you got sort of a nice clear view out to the rocket. Yeah, so a lot of people, some friends of ours were at Cocoa Beach, and they had pictures that were as good as ours on the NASA Causeway. So Cocoa Beach was perfectly acceptable place to go and watch it. And, there's great restaurants there. You just sit at a restaurant and watch a rocket go up. So, just take the drive. Anyway, let's get on with the actual show. In case you're wondering what it is that you have stumbled into, this is going to be a live episode of Astronomy Cast. First episode of, I guess it's the second episode, but the first...
Yep, second. You're right, second episode.
The second episode of season 11. So, wow. And we're going to do a show about fire in space.
And we have some pretty awesome announcements at the beginning of the show.
Yeah, so we'll do that first. So let's do the announcement at the
audio
beginning.
starting. I think that's a good place to start.
Yeah. No, but so we'll do an announcement, which you're all gonna want. You are gonna want to find out about right away because we're probably gonna run out of space. So I would sign up for this. So let's go from there. So let's start up the Audacity.
Do we have to do a countdown?
Nope.
Oh, using the wrong mic, fixing to the correct mic.
Testing. I'm on the right microphone.
Testing.
That's okay.
I have no idea. Yes, I am now on the correct mic. Okay.
Awesome.
I ready to press record?
I have already pressed record.
I am recording.
All right. Great. All right, and then let me just get my intro going.
I adjusted my gain so that whatever poor sod edits this doesn't get their eardrums burst out.
Okay, here we go. Astronomy Cast, episode 420. Fire! Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Great. Welcome to season 11 of Astronomy Cast. Now, we had an episode that you brought back from Dragon Con last week, but this is our first live show back together again here on the interwebs. So it's good to see you again. Although we saw each other in person like a week ago.
Yeah, so we did our normal thing, never see each other in real life while recording, but we got to hang out down at Kennedy Space Flight Center last week and watch the magnificent Osiris Rex launch off on her mission to pick up a rock and bring it back.
That was fantastic. And then we've got lots of exciting things planned this season. But we've got sort of one big event that we want to let you know about now so that you can prepare for the next year as you get yourself organized here. August 21st, 2017, there will be a total eclipse of the sun that is going to pass through the United States from the western United States, Oregon, down to Nashville. And you, Pamela, happen to live very close to the eclipse path, within a few dozen kilometers. And so we are collecting together. We are making our way to your house next summer to watch the eclipse, and we want you to join us.
Now, not everyone fits in my house. It's a nice house. It's a pretty large house, but it's not big enough for all of you. But over in St. Louis, there's this amazing hotel called the Moonrise Hotel. It's decorated entirely with Apollo mission stuff and things and space, and it's amazing. And we are going to spend a couple of days at the Moonrise Hotel talking science, talking astronomy, learning how to take photos when the eclipse is in the process of getting ready to happen. Actually watch the eclipse. Do not take a photo while watching the eclipse. Just watch it. But you can program your... Anyways, we are planning a great activity out of the city of St. Louis. We are going to be renting buses to ideally go to join everyone from NASA at Southern Illinois University Carbondale on the day of the event. But if their weather's bad, we're going to have a bus. So we'll go where the weather's best. We'll drive up to Mizzou if we need to. We'll stay in the St. Louis area. And so we have a registration cost tied to this that covers the bus, covers the room rentals, covers snacks, and pretty much breaks even if we get the minimum number of people required per bus. And whatever's left over is going to go to supporting Astronomy Cast far into the future. So go take a look, sign up. If you don't want to stay in the Moonrise Hotel, that is completely okay. Stay at a campground, stay at a lower priced hotel. It's like 100 something a night anyways for the hotel, so it's fairly cheap. And we've done everything we possibly could to make this an affordable trip for anyone who wants to join us. And I'm really hoping you'll come out. And we're probably going to do some extra things the days beforehand if we find out that people are coming out early. So, like, if you want to come out early and go on a massive bike riding tour of the area with me, I am happy to do that. But we want this to be fun. Yeah. This is a gathering of our Astronomy Cast family to watch a solar eclipse.
Yeah, so we will probably do some live. We'll probably do like a couple of impromptu episodes of Astronomy Cast that we'll save into this. So you can watch us do the show, but in the same room. We will, we're probably going to have some special guests and friends there who we will try and do some other interesting, entertaining events while you're there. We'll probably have telescopes kicking around, and we're just going to hang with you for the couple of days leading up to and after the eclipse. And hopefully, it'll be a great adventure. We'll all do it together, and it's not that expensive, and I think it's going to be a lot of fun. So how do people find out more about this, Pamela?
Go to astronomycast.com, and there is on the main navigation menu a drop down that says trips. This is currently our only trip. That could change, but currently this is our only trip. Or just go to astronomy-cast.com/astronomy-cast-solar-eclipse-escape-2017. I don't expect you to remember it. Really, just go to astronomycast.com, click on the trips, and there you go. Help us explore Greater St. Louis and watch an amazing solar eclipse transversing across these United States.
Fantastic. And I think these are gonna be gone pretty quick. So I think, if this runs out, then we'll try and find some other places. Maybe we try and expand.
Yeah, we're currently capped at 100 people because that's all that fits in the room. Yeah. And that's exactly 2 buses of human beings. But if all 100 slots are gone and I have enough time to find space at another local facility, I will gladly do that. So feel free to add work to my life by coming out and joining us.
All right. Okay, so let's get on to the show. I know this is a super long intro, but it's worth it. I think it's going to be really exciting. We'll keep reminding you. All right, so one of the most dangerous things that can happen inside a spacecraft is fire. Seriously, it's NASA's worst nightmare, and for good reason. Fire acts differently in space, and astronauts are always on alert. Here's why. Before we go into this, I think we should talk about how the suggestion for this week's episode came about. So can you tell the story?
Yeah, so we were having various things and stuff happening with CosmoQuest. Basically, I was running budgets. I hate running budgets. Budgets are my worst nightmare. I can do them really well. I'd rather not do them. Anyways, so I am in the middle of trying to sort out receipts and budgets and finding things, and Susie pings me, and she's like, what topic should we do for Astronomy Cast? And I wrote back, putting out fires, referring to the invoice I was looking for. And she was like, great, fires on Earth or fires in space? I was like, that's not what I meant, but we'll go with that. Fires in space. So,
yeah. And I heard it too, and then I just thought that was brilliant. A great title. So so I said, let's do it. Let's go with it. I'm on board. And because it is actually a super fascinating thing, and there's been some recent development in this exact place where NASA's been testing out fire in space. So let's go back around. So before we talk about fire in space, let's just understand what fire is first. It's time to bring out some kind of triangle. What is fire?
Well, fire is basically a chemical process by which a fuel gets it goes through an exothermic process in the presence of oxidizer that changes the molecular structure of that fuel. Often the heat released in this exothermic reaction makes things go kablooey.
Right.
Kablooey is the official term. I'm going
Right.
to go with that today.
And in order to have fire, right, you need to have an oxidizer, you need to have a fuel source, you need to have heat.
Well, the heat kind of gets produced in the process.
But that is the triangle, right?
Yes.
So you need those three things, and then you get fire. But how does fire work in space? I mean, it still works, right? Inside, now not out in the cold vacuum of space.
Oh, it can totally happen in the cold vacuum of space if you mix things.
Right, if you provided an oxidizer and you provide it
Fuel.
Fuel.
So you can have situations where you have your fuel, your oxygen, you mix them together. They undergo this chemical reaction. As part of the chemical reaction, the gases involved radically expand, and it's that expanding gas coming out the nozzle of either a rocket engine, a thruster, a navigation engine, any of these little things that you've seen in sci-fi and in reality that cause spacecraft to move, reorient, all those different things. That is generally a reaction involving, again, fuel and oxidizer. Mixing, chemical reaction gives off heat. Heat has expanding gas pushes.
So it's necessary. We need it. We need it
Yes.
for turning our rockets around and moving them faster, changing our direction, changing our orbits. So, but fire giveth, fire taketh, right? So if you get the fire inside, it's a bad scene.
Yeah, and one of the things that like I had never really thought about until I read about NASA's recent experiments is here on Earth when you have your handy dandy little candle. If you're a girl like me, people give these things to you as gifts on a regular basis. And you light up the candle and the candle goes up and then the smoke goes up and you end up with dirty ceilings you have to figure out how to wash eventually. This whole things going up process is because warm air is more buoyant. It is less dense. It floats in the more dense air around it. And that whole buoyancy is in response to gravity. You remove the gravity, you remove the buoyancy. So you have a burning flame in space. Nothing's rising. Instead, you simply have the warmth gathering in a glowing sphere around the thing that's burning. So light that exact same Yankee candle on the space station. This is not what they use on the space station. But if they did, you'd have a perfect sphere of flame around the wick. It would glow a slightly different color because it's this condensed circle. It's actually burning at a lower temperature. And here on Earth, your heated air goes up, causing the cooler air to come in. You have circulation going on. In space, you just have diffusion. So oxygen molecules are doing their normal happy little bounce around, flow in through their normal motions thing. And that totally changes how things burn. And this is a video of a recent fire experiment that took place on the International Space Station. Not on the station, they had it like exterior to where the astronauts are. I haven't seen it this big. I watched it on a phone. So if I like suddenly go silent, it's because wow, that looks a whole lot more dramatic when watched on a 27-inch cinema.
Yeah, part of the sort of new improvements we've made to the way we broadcast Astronomy Cast is we actually do this live as video, and we've got a really cool broadcasting system, and we're displaying video to the audience, and it is entrancing Pamela and distracting her. So remember, we have audio listeners, Pamela.
Yes, sorry, audio listeners. So they're dealing with flames in space is something that NASA has to figure out how to do. So far, we've been extraordinarily lucky with the ISS, with the space shuttle before that, with the Gemini missions before that, and with everyone who made it into low Earth orbit and to the moon in the past. Part of the reason that we've been lucky is because we only use high oxygen environments in spacesuits. The other part of it is so far there hasn't been an electrical fire, and that's just wow, thank you, universe. But at some point our luck's going to run out, so it's super important to understand how does fire go in space, so that when and if this kind of mistake happens, something goes wrong. I mean, it could be something as stupid as micrometeorite takes out the wrong thing. We know how things are going to burn.
Yeah, and we've had sort of one really horrible experience with fire in an enclosed space with the Apollo 1 disaster that happened. Yeah. Now, it wasn't in the zero gravity of weightlessness, but it showed you what happens when you've got fire in an enclosed space. In this case, this was the Apollo 1 astronauts. They had put 100% oxygen in the capsule, and like electricity sparks from the Velcro and caught on fire. It was awful.
Yeah. So the human body requires oxygen. We don't require all the other randomness that's in the atmosphere around us. We don't require all that nitrogen. Heck, too much carbon monoxide makes us sick. In putting together the early NASA missions, it's just easier to only have to carry the oxygen. You don't have to worry about the partial pressures. You can actually have it at a much lower atmospheric pressure and get everything you need into your bloodstream. But fire burns much more effectively when it has added oxidizer, and that oxy in the word oxidizer is oxygen. So in the extremely oxygen-rich Apollo 1 atmosphere, they couldn't put out the fire that was triggered quite by accident. They couldn't get out fast enough, and people died. And we try not to do that. That's an understatement. Death is bad.
Yeah.
And so in going back to the drawing board, figuring out what the problem was, and daring to do the difficult things, they re-engineered the atmosphere for all future space missions. And so now we have people breathing a oxygen, nitrogen mix. There's, of course, going to be carbon dioxide we exhale. And it's very similar to what we have here on Earth. And so we don't have this flash fire problem that was a concern on Apollo 1.
Yeah. So then, let's say that a fire does get started. You're talking about like a, micrometeorite happening, some kind of event that actually gets the fire going on in an enclosed space.
Yeah.
What do they do? What can they do to kind of prevent or deal with a fire in space?
So just to be utterly clear, the risk of fire on the International Space Station is extremely low because of all the effort that goes into protecting everybody. We're talking about an extreme what if that is scientifically super cool and bad for human beings. So if you do have a fire in space, first of all, you don't have the fire rising problem that you have on Earth. But this also means you don't have the smoke rising thing that you have here on Earth. So as all of us hopefully learned as small children, in case of fire, get down on your belly, creep forward while breathing as close to the ground as you can, because that's where the good oxygen is. Feel the doorknob, call for help, do all your safety measures. You're on the International Space Station, and a fire sets out. What you're going to have is things diffusing, and the only motion of that smoke and that fire is going to be the fire moving along whatever is burning, and also responding to the space station's spaceships, whatever space thing you're on, responding to the ventilation system. There is constantly moving air on the International Space Station, so you don't end up with your head in a pocket of carbon dioxide and die. Again, death bad. So you do have this steady ventilation, this constant movement of air that keeps things circulating, keeps the oxygen coming in, keeps the carbon dioxide moving away. In case of fire, you're going to have the fire moving along that ventilation system. Bad, because the ventilation system is meant to move things effectively. You're also going to have whatever is on fire can burn at a much lower temperature than here on Earth. We're all familiar with the book Fahrenheit 451. 451 degrees Fahrenheit is the temperature at which paper spontaneously will combust in a normal atmosphere. It doesn't need to be that hot on the International Space Station. That's a bad thing. Things burn at lower temperatures. So your number one priority is going to be remove the oxidizer from where the fire is, remove the fuel source. Anyone who's watched good sci-fi knows one of the favorite things to do on a spacecraft in a science fiction movie is you flush the atmosphere and the fire goes out. It's
Right.
cool. With the International Space Station, that would probably be bad. Thinking in terms of, in general, you want to prevent the fire, stop it by sealing it off, removing its ability to get additional oxygen. So that idea that you have with a stove fire, if you put the pan on the pot, it puts itself out, totally applies in space. So as long as you can have the fire confined, ideally floating in the middle of the room with no fuel to jump towards.
Right. Yeah.
I can imagine floating over to it frantically and closing it inside of something airtight. That's the best of all possible cases. But the next case is you shut off the ventilation, get yourself somewhere different, and let fire extinguishers take care of it.
Yeah. Yeah. So that's the issue is how, flushing the atmosphere, we're using the atmosphere too, right?
Yeah.
So, it's really rough to be able to use to go and hit the vacuum, flush all the atmosphere of your spacecraft, when you're using it. It's not as simple as they make it in science fiction. I guess, it's not like they have these emergency doors that they can just, and the whole atmosphere goes out and you lose all your stuff. So it's a pretty sketchy solution to it. So what about extinguishing systems? Can you spray water, fire retardant, fill with carbon dioxide? What can you do?
Definitely a thing. Well, you can use chemical fire retardants. You can essentially cover them in something preferably adhesive so that you aren't doing horrible things to the atmosphere of your ISS, which has already gotten horrible. So you can use all sorts of fire retardants. You can use fire retardant blankets. The whole smother the fire, that's totally an awesome idea in outer space.
Right. But I just, here on Earth, right, throw a blanket over it. You've got gravity working to help hold your blanket down to put out the fire, to smother it, right? But there, you've you
have human beings who have to literally best case is I have a cup of fire floating, and I probably shouldn't do this with my NASA cup. I have a cup of fire floating in the middle of the room, splashing fire all over the room, and I either spray it with something that will adhere to it or take fire retardant blankets and make a sandwich of fire.
Yeah. Yeah. I just think of the aerial ballet required for astronauts to grab a blanket, to meet in the middle where the fire is happening, and to make this fire sandwich. It's bad. So, let's focus on the fire retardant system. Let's focus on smothering it with carbon dioxide or some kind of chemical thing. But again, once again, right? On Earth, you've got gravity to help keep your method of extinguishing the fire together with your fire, right? You spray your water, and gravity takes your water down onto the thing that's on fire. You spray your fire extinguisher, and the gravity is helping with this. But in space, you spray your water or you spray your chemical blast, and it could miss the fire and then bounce off the back wall of the spacecraft and bounce around. And like, this is bad.
Yeah, it is. Now, one amusing thing that water, space, bad electronics, you don't want to destroy them. So different parts of the International Space Station are run by different countries. There's a Japanese module, there's a Russian module, there's American modules. The Russian module actually does have a water-based foam fire extinguisher. Again, foam, it adheres to things. The other modules have carbon dioxide units, so similar to what you might have in your kitchen, but designed slightly different. Jet propulsion system. I love the fact that your poor astronaut who's trying to put out this fire is essentially bracing themselves to counterbalance the jet propulsion unit in their hand that they're trying to use to put out the fire.
That's right. Your fire extinguisher is a propulsion system, right? Which is just hilarious. So
And as what's on fire, if it's there, like if you have your fire floating in the middle of the room, it's going to like get jet propulsioned by the fire retardant. This is bad.
This is bad. I mean, I think, NASA makes sure that every single little thing is not flammable.
Yes.
Right? Like
Yes.
from the casings of every wire, from everybody's clothing, from everything. And we saw that in The Martian, right? You remember?
Oh yeah.
Remember
Nothing
in The Martian?
burns.
Yeah, there's this whole part where Matt Damon is saying like NASA is really afraid of fire, and and so
for
nothing.
reason.
Yeah, for good reason. Yeah, and so nothing burns. And the only thing he could find that he could burn was to cut up pieces of a little wooden cross. That was the only thing that he could get his hands on throughout the entire spacecraft that would burn, and that is the level of how serious NASA takes this. Now, did you see the movie Gravity?
No. I was warned by people like you that it had bad physics in it, and I would be shouty.
Oh, so shouty. But right, so there's a scene in that, right, where the fire was like moving along, and it moved in a really different way than we would see here on Earth. And I think it's the way you described it, right? That it sort of crawls along whatever flammable surfaces it can reach. It, puts out its smoke in a sort of, right in a circular, yeah, that's right, in a sort of a spreading way, which is sort of a different world. So
Don't stick your head in the blob of smoke.
Right. It's going to be hot and smoky in there.
But think about how different this makes your thinking on where to put fire detectors. Because here on Earth, at least on my house, which is on Earth, we have fire detectors in like every other room of the house. It's an old house. It's been on fire twice. We don't want this to happen a third time.
Your house has been on fire twice?
Yes.
Oh, wow.
Yes,
Okay.
It was built in 1893.
Yeah.
These things happen.
Okay.
And so all of these smoke detectors are like 3 inches from the ceiling. And this is because smoke rises, the smoke interrupts a electric field inside the detector, causing a change in voltage, which in turn causes a noise that scares everybody in the house, especially the dog. That doesn't work in space, because your smoke is expanding in a sphere from whatever was on fire if your ventilation is turned off. And if your ventilation isn't turned off, your smoke is expanding in the direction that the ventilation pushes the smoke. So you have to think about putting all your smoke detectors basically following the airflow and near whatever might possibly, like electrical fire or something. So even just thinking about where to put fire detectors becomes radically different when you're in a zero-G environment.
Yeah. Oh, what a total nightmare. So now we talked about this briefly, the experiment that NASA did, which was to light a fire in space. Like literally, that's rule number one, right? Right? Like don't take off your space helmet and don't light a fire. Like those are just 2 rules. And yet
Yeah.
they broke rule number 2, which was they lit a fire.
Yeah, it was, and the videos of this are amazing. We will embed one in our show notes. The experiment was called Sapphire, because why not?
Yep.
I
Got fire in it.
amusingly, the flames are extremely blue and circular, so they do kind of look like a color of a sapphire gemstone. And it's just this amazing sphere when they do the small experiment, but with the big experiment, they have a heating element that combusts the fuel, which has oxidizer, and the flames just move along the fuel and eat everything up. It's this beautiful. It looks like if you've ever started a chemical reaction, for instance, adding red dye to something and seen it spread out through water, it's that same sort of just continual smooth movement across the fuel.
Yeah.
It's stunningly beautiful.
Yeah. And the people who watch us live will get a chance to see this, while the people who are listening to on audio, I can make some sound effects, maybe. Yeah, really cool, and really, like, just reckless. Not reckless. I mean, the trick is they gotta know how this works. And
Yeah,
so
they have to.
They do the experiment, see what happens, and then and then they can learn what happened, and then use a way to prevent it, so they can try and predict and prevent the fire in the future. So, Firebad. Okay, well, I think we're sort of out of time, but Pamela, thank you for
my pleasure. And
the brain
for any of you who are willing to take your love of listening to our show and help us make this show better, one of the things we're also going to put out on our website is a link to a survey about podcasting. We're currently doing a funded research study that is approved for publication through our university's internal review board for people who just want to make sure we dotted our I's and crossed our T's rather than dotting our T's and crossing our I's. We have a link to the survey. It's going to be on astronomycast.com. Check it out. Fill out the survey. It will help us understand how to improve podcasting. And since we're publishing the results, it won't just help us here at Astronomy Cast. It's going to be used to help everyone out there doing podcasts. So please take a moment, go to astronomycast.com, click on the link for the survey, take a few minutes, and help us just do better, making you enjoy or helping you enjoy.
Forcing you to enjoy.
We can't force them to enjoy.
Yeah. All right. Thanks, Pamela.
My pleasure, Fraser.
So now we stop that.
Yeah.
And for those of you who haven't witnessed us do this before, this is when we try to use our computers while talking live on the internet.
Don't go anywhere.
No, we will be back to answer your questions once we have saved.
I'll save the project to the desktop. 420. People were making 420 jokes.
Well, naturally.
Yeah, naturally. And then I export it as a wave. Yeah.
As you do.
As a wave file. I got trying to bring Chad up to speed. Now we have another human being here, an engineer, as it were.
Now you don't have the sniffles or coughing. Did you escape the Osiris Rex launch plague?
Mm-hmm. Yeah.
You were very.
I brought it.
You brought it.
Yeah. I shared it. Were you a little?
Yeah.
You were a little sick.
Airplanes. So.
Oh.
Yeah.
Oh.
Carlo was sick too. Yeah. Yeah, I don't get sick is the problem. So, but fortunately, I'm also, not in any way believing in pseudoscience. So I don't think that I just jinxed myself. Okay.
Yeah, you're past the incubation period. You're good.
So Sean Harlow says, so basically, if I had something floating and on fire, I could be Super Mario in space.
Yes.
Well, yeah, it's like because you're throwing flaming fireballs?
Or something.
Is that how that's working? Propelling fireballs around with jet blast? But every time you throw... See, when Mario throws the fireballs, nothing happens to him. He just throws the fireball. But if
That's
you're in
true.
space, every time you threw a
go
fireball,
too.
you would go the opposite direction, which would not be as effective as you're hoping space Sean Harlow Mario. So, yeah. Cole Morgan asks, I understand there's a lot of materials on the ISS that could ignite, but given microgravity in an area with more sparse fuel, wouldn't the fire have a really difficult time spreading? We hope. Yeah, everything's nothing's flammable.
This is something that like it would be massive freak accident of like the right four things happen to somehow get smashed together by something. Yeah, this should never ever happen. We're just talking about what ifs, and NASA has to worry about the utterly improbable what ifs. Because again, death bad.
Death bad, fire bad. Some people were asking about how this is episode 420 and the last episode for the last season was 418. What happened to 419?
It was recorded at DragonCon. It's in our feed. There was no video because of the session we were in DragonCon.
Yeah.
It's on Rocket Girls, the women who helped found JPL.
How was DragonCon?
We missed you.
Oh, maybe next year. Although we're going to be busy with the eclipse. But anyway, maybe next year.
It's after the eclipse. Stay at my house and fly to DragonCon with me.
Maybe. I bring a large crowd. I bring an entourage, as it were.
I'm good with that.
I promise the kids.
We have a big house. They're fine. They're welcome.
All right. I got to book a hotel room. Unless you've already got that covered too. Let's see. There was a big.
Accidentally closed the pop-out chat.
Did you?
Yeah. I can reopen it.
So we're happy to take any questions you might want about space and astronomy, or watching eclipses, or what we learned from DragonCon, or like what does it take to be a podcaster in this day and age? Whatever you want to know, we're happy to answer your questions. Or we'll just shut this down, and you have no one to blame but yourself. I'll go eat lunch. I don't mind.
I'll make more coffee.
So John Suffield asks, didn't Mir catch fire at one time?
I think it did, but again,
Mir
the Russians have
fire,
a different
yeah.
ways of doing things.
Yeah, Soviet Russia. Yeah. I can't believe we.
Website.
Oh, Universe Today has a really great story about fire in space. We didn't even talk about the Mir. Oh.
We both had just blocked it from our minds. We were talking about
okay,
the
hold on.
shiny,
Go up
beautiful
for a second.
research.
So I got a quote here. Can you go up for a second? Stop. No, keep going. Keep going. The other way. Up. Stop. Okay, so NASA fire expert David Urban told Universe Today that a fire is among the most catastrophic situations that a crew can face. You can't go outside. You're in a very small volume, and your escape options are limited. Your survival options are limited. That space can tolerate a much smaller fire than you can tolerate in your home. The pressure can't escape easily, and the heat stays there, and the toxic products are there as well. Ugh, that is it in a nutshell, right? Like just you can't get away from it. The toxins build up. Everything's Ooh. Yeah, I wish we'd brought that in. Jason wants to know why dogs have cold noses. Why do dogs have cold noses, Pamela?
Because of evaporation.
Snap. Citizen Gold wants to know how long after the eclipse is DragonCon?
Like a week later.
Yeah. I wonder if they're gonna overlap PAX this year. I'm feeling slightly ambitious.
I will pull up all the dates because I consider that
I got
awesome.
like a week's worth of heavy planning right now of PAX, Eclipse, DragonCon, Comic-Con, VidCon.
So DragonCon is September 1 to 4, so it's a week later. And then PAC Con? I don't know how to look it up. PAC Conference.
Yeah. Anyway, we'll do this after. Jason Rivard says, have you done a show about cosmic voids? Have we ever?
Yes, we
just
have.
in the last season, we did an episode. Now, the problem is it doesn't say cosmic voids, I don't think, but it's the one that we did
Paul Sutter.
with Paul Matt Sutter. So if you do a search for Paul Matt Sutter, on Astronomy Cast, we did a whole episode just with him, and all we talked about were cosmic voids, and it's one of my favorite episodes. So give that a crack. Paul is really knowledgeable. This is his area of specialty, and it was a real treat to sort of just have have an episode of Astronomy Cast, but have him there as part of the conversation as well, which was great. Cole Morgan wants to know how biofilms form in microgravity.
So what's cool is because you're not limited to a flat surface, you end up with lots of spheres.
Whoa.
One of the early things that they talked about in the space shuttle program for justifications for moving to get into space is you can build crystals. You can have crystals grow that don't have to grow on like a stick on the wall of the container. Right. And so now you can start building perfect crystals that are floating in a spherical blob of stuff.
Yeah.
And so you end up with, when you grow films, you can now grow a film on a sphere of water or a sphere of stuff.
Yeah.
And it just changes how you think about them. And of course, this changes the bond angles and all sorts of cool stuff.
Oh, Elad Avron had a question and forgot. We can wait, Elad. We'll just wait. Okay, so Lillian Brennan wants to know, so if things burn at a lower temperature in space, what about the boiling points and melting points? So those differ. So they're not burning at lower temperature, are they? I mean, the temperature that things burn is dependent upon its chemistry and the air pressure and things like that, right?
Well, so the air pressure plays a slightly different role when you don't have heat rising.
Yeah.
So if you look at a candle, you have this whole distribution of temperatures, and the flame in 0G doesn't have that. You have this beautiful ball of blue, which means super hot flame, instead of this beautiful, tall, wiggly, yellowy, much cooler flame.
Yeah.
So the overall effect is you end up with, I'm trying to figure out how to explain this coherently. Because you don't have the heat getting spread out with a little tiny super hot area, the overall effect is you can have a cooler overall flame that leads to ignition than if you were on Earth.
Yeah. Paul Stewart likes this new upside down land friendly time slot. We did this just for you, Paul. We reorganized our whole schedule to make sure that the upside down astronomer could be here and join us.
We are deep fans of our Australian and New Zealand fans.
Especially if they're upside down.
Yes.
And Guido loves the Friday evening double feature. Yeah, this is, I think you saw our realization of this last season where we were like, oh, we got to do Monday, we got to do Friday, and then I forget how it came together. But I believe in the show, we were like, why don't we just do them on the same day? And then it's a lot easier, and then I don't have to find internet twice a week. I only have to find internet once a week. Of course, now I am in the process of adding a new show on Mondays, so I can't help myself, which is that we're going to play video games on Mondays. So we're going to play space games like Kerbal Space Program and Universe Sandbox and things like that, and just have a special guest. So if I can get like an astronaut or an astronomer, and we'll just hang out, and Logan's going to play the game, and I'll chat with the astronomer, and we'll have an audience, we'll ask questions, and be very kind of low stress. So if you want to join us for some video games sometime, let me know.
One of my favorite moments of the Osiris Rex launch was one of the most brilliant programmers I know was deeply confused by the fact that they went straight. They never went into low Earth orbit with Osiris Rex, and I was trying to explain, but they would have lost momentum. It's just easier, big rocket, small ship, just off and go. And he's like, but it doesn't work that way in Kerbal Space. Kerbal, but not in Kerbal space, was the way that people were.
You could do a launch to insertion orbit directly on Kerbal Space Program. It's just our puny human brains can't calculate the full, like, the way we do it in Kerbal Space Program is first thing we do is we get into an orbit, and then we make a change in the orbit to go to whatever is going to be our new objective. So that's pretty funny. So one thing just to show people is a new addition to the show is this chat thing down here.
Over there.
Yeah, it's this chat thing down here. So what this is the WSH crew, who are, our longtime fans and really our producers and partners in the shows that we make. This is their community and this is their Slack channel. So we have the YouTube chat, which we're still kind of watching, but this is the real chat right here. This is where the cool kids hang out. So if you go to the WSH Crew website, and I'm sure now they're scrambling madly, there will be information on how to join the WSH Crew's Slack channel, that from within which you can then participate in the live chat during the show. So there's no way we're going to drive the YouTube chat through the show, but we're totally glad to drive the Slack chat through the show. So go join the WSH Crew, go to their website. There'll be information there. I'll let them figure it out because they do that. Yeah.
And the WSH Crew works closely with Astronomy Cast, Universe Today, CosmoQuest, all of the things that Fraser and I work on together. And people who are closely involved in that never know when, like, one of the two of us are going to pop in and be like, can somebody look at something new we're trying to do?
Yeah.
And
I need we often pull in volunteers to help us test technology and stuff. So Brian Brown just asks, is this chat room different from Slack? Right. So the thing you're chatting is the YouTube chat, Brian. The thing that we're planning is the Slack chat, and that's part of the WSH Crew has a Slack channel. It was great. We had a Slack channel for the Osiris Rex mission. Sandy had set it up, and so we were all able to chat and coordinate and talk to each other and plan where we were all going to be and stuff. It was really helpful. So so go to wsh-crew.net, and there will be information, and we'll keep explaining this to you week after week after week, and sort of people can find their way over to this community, and they're wonderful people. So if you are totally stoked for space, these will be your new friends.
Join us.
Okay, great. Well, speaking of joining us, don't forget about the eclipse next year. Seriously, like, I think these are going to go. So if you want to do this,
join us.
We should wrap this up. Thanks, Pamela. Thanks to the WSH Crew for being willing to try another of my crazy experiments. And thanks to all of the viewers. And thanks to the moderators in the YouTube chat. That was a hell of a thing. We'll see you guys later.
See you.